Alright, in 7.2 we talked about terminating decimals. Do you guys remember how it was we decided a decimal was terminating? Long division, we used factoring to see if the denominator had 2's and 5's, and it had to be in simplest form to do it. Is everybody good with that? We did that in the last section. What we're going to do in this section is we're going to take a look at what happens when the decimals are not terminating decimals. Alright, so we said that we had to have things in simplified form. Another way to talk that is about the idea that a fraction being reduced, right? And then once it's in that simplified or reduced form, we look at factors in the denominator. And if they're only 2, 5, or both, right, or some multiples of 2, like 2 times 2 times 2, 5 times 5 times 5, or has some 2's and 5's, then it terminates. And it's actually easier to talk about when it doesn't terminate. It doesn't terminate if it has any factors that aren't 2's and 5's, right? So if you see 3's or 7's or 13's or something like that, then you do not have a terminating decimal. So what if the fraction cannot be written as a terminating decimal? Well, if we still have a fraction that's written as an integer over an integer, which is the ones we're going to look at today, that means we still have the ability to reduce and to factor the denominator, all that good stuff. Then if it doesn't terminate, it means that it repeats. Okay, so it does this repeating fashion. Maybe it repeats after one decimal. Maybe it goes 0.3333333. Or maybe it does something where it repeats 2 decimals, 35, 35, 35, 35, or something like that. If we have the ability to start out integer over integer, we can reduce it, and the denominator does not factor into 2's and 5's only, then it will be repeating. So the first thing we're going to do is we're going to actually look at how we take a fraction and know when in fact it starts repeating, so that we can actually write the decimal in a repeating fashion decimal form. Okay? So take a look right here. We've got the fraction 1 over 24. How do I know that this is a non-terminating decimal? Because the denominator has a factor of 3 is the issue, right? If I were to factor it down into prime notation, the 3 in the denominator is the problem, right? Because this 24 would actually factor, and I'll write it like this, into 2, and that's 12. 12 divides by 2, and that's 6. 6 divides by 2, and that's 3. All those 2's are great. I have no problem with all those 2's. But the 3, that's a problem. Okay, so I know that this is not going to terminate. I'm not going to ever get, when I do the long division, a remainder of 0. It's not going to happen. Okay, let's see what does happen, though, if we're trying to turn it into a repeating decimal. So we do it the same way that we would have done for a terminating decimal. We attempt to do 24 and divide the number 1 into 24. And so we add our decimal point and some zeros, and we add as many zeros as it takes in order for the number to actually be large enough, ignoring the decimal, to actually be divisible by 24. So I think we actually need the number 100 before that will happen. So how many times will 24 go into 100? 4. Okay, so I'm going to take the decimal point and move it up. And I wasn't able to divide the number 10, so there's a 0 here. And then I have a 4 here. Is everybody good with that process? Remember how to do that? Okay. All right, so what's 4 times 24? 96. And if I subtract 100 minus 96, what do I get? 4. And then I tack on another 0 to bring down. How many times will 24 go into 40? Once, And then I would subtract 40 minus 24. What is that? 16, good. I'm going to include another 0 here. I've got 160, so to speak. How many times will 24 go into 160? 6. What is 6 times 24? 144? Okay. And what is 160 minus 144? 16. And I know I can stop there. Any ideas why?
It's just because you already got 16.
I already got a 16 as a remainder before. This 16 matches this 16. Once the remainder that you get is the same, you're done. You just have to figure out how many numbers are then repeating. Well, on this one it's pretty easy because it was the step right before. So if I actually tried to do this again, I'd get another 6, wouldn't I? And then I'd still get a remainder of 16, I'd get another 6, and I'd get another remainder of 6, and so forth. Remainder of 16 and get a 6. So it's only the 6 that's going to repeat here. And if you aren't sure, you could actually do a couple more iterations of the division to actually see that you're seeing that 6 show up more than once. You could also double check with your calculator to see that what you're anticipating happening really is justified as you look at that sort of representation. So the decimal representation is actually a decimal point, a 0, 4, 1, 6, and be very careful that the repeating bar is only over the 6. It's really easy for it to start looking a little too long, and I have to have questions about what it's really repeating. So it's just the 6 in this case. So we call this kind of decimal a repeating decimal. And the repeating block of digits, in this case just the 6, is called the repeatant. I have a wonderful note on the bottom. Can somebody read it out loud for us just for fun?
I expect to see division with numbering these.
Do I expect to see the division? Because that's what you would expect your students to show you to. Okay? So practice it a few times, please. All right? Yes, Beth.
When I put in my calculator, I get like a 7 out of it. Is that?
Like it will eventually give you a 7?
Yes.
Yeah. Your calculator, what it will do at the very, very end of however many decimals it shows is it will round that last decimal.
Okay.
And since the 6 would force the next decimal over to round to a 7, it will eventually show that. But that's just because the calculator is rounding at some point. Good question.
Did you say we're gonna have to know like how many times the 6 would repeat?
Yes, and I'll show you another example so we can see something where it's not just once. So hold tight with that.
So I just repeated once here.
Well, no, it will repeat forever.
Okay.
Okay. Because every time I do this and I try to do the 16, I'm going to get 160, and I'm going to get the 144, and I'm going to remainder 16. So once it's repeating, it's going to repeat forever. All right, let's take another one. We have 29 over 99, and the directions are the same. Find the decimal representation. 29 is prime, right? Yeah, there's no factors that divide 29 except for itself and 1. 99 does divide. What would it divide into? 3 and 33, and then that would be 3 and 11, right? So 3, 3, and 11, those are all prime numbers as well, and actually none of them are 2s and 5s. So there's all kinds of problems. This is definitely a repeating decimal, right? Definitely doesn't terminate. Now, we don't have to actually sort of think through that to do the next, what it's asking me to do. But being aware of what you're sort of expecting to happen at the end is a good idea. All right, so we start the process the same way as the last one. We've got the 99 up here. 29, I've got a decimal point in 0, and I'll pull my decimal point up. So basically looking at the number as though it was 290. How many times will 290 go into 99? I said it the wrong way, sorry. How many times will 99 go into 290? 2 times, yeah. All right, so what's 2 times 99? 198. And if we subtract, what do we get?
92.
Yes. Okay, so there's a remainder. I'm going to add another 0 or include another 0, so to say, on the end here. Now I've got 920. How many times will 99 go into 920?
9.
That is 9. 9 times 99 is 891. Okay. And if you subtract, what do you get? 29. And I conclude that I'm done. Why?
Because you started out right.
Because I already have the number 29 that I did this with once, right? Now this one's different than the last one because it wasn't just the previous step, was it? It was actually how many steps back? Actually 2 steps back, wasn't it?
Yeah.
I'd actually have to go up to the last subtraction was right here, and then the value right here would have been before. I'd actually have to go up 2 steps in order for that to happen. So how many things are actually repeating? 2. The 2 and the 9. And again, if you're not sure, you can find it out easily. You just keep doing the process. You you say, okay, well, I don't know, is it just the 2 that's repeating, is it just the 9 that's repeating, or is it the 2 and the 9? You know, how many of these things are repeating? We'll just do it again. So if you weren't sure and you did it again, you'd bring another 0 down. And you'd say, oh, I've got 290. How many times will 299 go into 290? 2. 2 times 99 is 198. And then I have a remaining 92. Right? 920, that's a 9. It's 891. Right? I did it 2 more steps and I see, look, there's the repeating value. Both of them repeat. Does that make sense? So if you're not comfortable with simply figuring it out based on where it was you had that same remainder, just do a couple more steps and it'll become very clear how many values or which ones of the values are actually doing the repeating process.
So on our homework, if we do like 0.29, 29, and we did the bar over the whole thing,
That would be incorrect. No, that would be incorrect. You can look at this to see that it repeats, but the answer needs to be written like this.
Okay.
We write the bar over as few decimals as we need to indicate the repeating pattern. Did you guys understand what her question was? So we would not write this as 0.2929 with a repeating bar over all 4 of those. We want the repeating bar to be over as few number of digits as conveys the information we need.
If you like put 0.292, just put a bar over the last 2 that's
You're still reporting more information than needs to be shown to convey the same thing. So it wouldn't be wrong, Kenzie, and it wouldn't be wrong, Ashley. It would just be overemphasizing what's already there. It would sort of be redundant. I mean, that's kind of the deal, is that you're sort of being redundant in the way that it's expressed. So it's kind of like the idea that it's not in simplest form. It's like that. It's like that idea. And that's okay. That's okay. You can definitely keep that going, but then the answer needs to be in simplified version of that. Yeah. Okay, so what we've done so far in these 2 examples is that we've taken a fraction and we've turned it into a repeating decimal, right? We need to go the other way. We're going to take the repeating decimal and turn it back into a fraction. And this process you may or may not have seen before. I saw it at some point. I don't remember, it was in high school. I know it was described to me in high school. But this process to change this back into a fraction is a little different. So walk through this with me and I will show you. Notice that this repeating bar is actually over the 6 and the 1. Do you see that? Okay. So this fraction being over the, this repeating bar being over the 6 and the 1 is important to note how many places it's over. So the first thing you're going to do is you're going to write down n equals that value. You're just going to give it a letter name. Letter name you're going to give it n. You could use something else if you wanted to, but what goes with it. Okay. And what you're going to do is you're going to multiply both sides of the equation that you now have by a power of 10. So you're going to multiply it by 10 or 100 or 1,000 or 10,000 or something like that. The question to you should be asking yourself right now is, well, which one do I multiply it by? Well, it depends on how many decimals are repeating. This one has 2 repeating decimals, right? React. That's good. Let's try that again. Repeating decimals. So you're going to multiply it by the power of 10 that has 2 zeros. That's the number 100. So if you had only one repeating number on the side, what number would you be multiplying by? 10. If you had 4 repeating decimals, what number would you be multiplying by? 10,000. Is everybody good with that? The number because things are not going to line up if you choose the wrong thing. It is really important. Things will not work out properly. You multiply by the number on each side that has the right number of zeros that line up to the right number of decimal repeats. Now if you do that, let me put it in here.
So if it was 0.612, it would be 3. Or, I mean,
We're going to do another one here in a minute, Kristen, and I think it'll answer your question. Where it has a weirder, weirder's not a good word, is it? It has a stranger way of looking at it, yeah. So give me a minute and it's the next example. On the left, this is fabulous. This is 100n, no problems. On the right, this is a little weird. So you mentioned, Kinsey, that you had to write things out to see what they were doing. So let me write this out a little bit to see what's going on here. Right, and it keeps going, right? But this is the process. It goes 6, 1, 6, 1, 6, 1, 6, 1. So what happens if I multiply that by 100? No, it moves the decimal, Hannah, right? What will the number be now before the decimal? 61. What will happen after the decimal? It'll still have the 6, 1 repeating, right? So I'm going to write that then as 6, 1 repeating. Are we okay? Okay, so you're still probably thinking like, why? Here's why. I don't want that repeating decimals there at all. I want them to go away. It's because when I write it in fractional form, I can't have a repeating part inside of my fraction, right? You know, that's not proper. There's nothing about that you've ever seen where a teacher said, yeah, just leave that repeating in the middle of that fraction. No, you're mixing notation. So what are we supposed to do? Well, what I'd like to do is I would like to get rid of the 0.61. I'd like to subtract off 0.61. And they line up now, right? They line up. What does 0.61 repeating equal? N. Because that's where we started. It's not magic. We started there.
I don't understand.
We said it. We said at the very beginning, N is what we're going to call 0.61. We're going to give it that name. The name we chose is that N is equal to 0.61 repeating. I don't think I've ever had a class that was confused.
Because it doesn't make sense.
We have said, we are the ones who gave it the name. We said N is 0.61. My goal is to get the 0.61 to go away. So I get the 6 ones to line up. That's what I did here, right? The 6 ones line up. Write them out if you want. 6, 1, 6, 1, 6, 1, 6, 1. They both are the same thing, right? They all line up. All the 6's in the same place, all the 1's in the same place. So when you subtract, they go away. So all that you're left with on the right side is 61. And I want the N expression on the left because I can't combine the 0.61 notation and the N notation. They are not like terms. But 100N and N are like terms.
Why can't we just cross
Yeah,
it
we
out?
are. What's 100N minus N?
99
Whoa.
Oh no, that's
whoa.
algebra. Don't tell me 100N minus N is 99N. There's nothing complicated on that step. You may not like the right hand side, but the left hand side should be just fine.
So then is that
Okay, now I got it.
Are you
just
with
give
me?
a minute. I'm sorry. Just gotta slow your roll. We're working with weird things, so
We're going to do another example, all right?
why can't we just cross it out and call it a day?
Because you won't end up with the right value.
I think it's fine.
All right, in the back over here, how are you doing, Morgan?
I think I get it.
You think you get it, Shayna?
So
Not for
because
sure.
we
Try
named
again.
it in, we can take it away. It's not like we're getting rid of some important, like we named it. So
Yeah, we gave it the name. We're subtracting the same thing from both sides. You guys do with fractions and stuff all the time, right? Where on one side you might subtract 1/2 and the other side subtract 2/4. But that's just because 1/2 and 2/4 are just the same values, it's just different names.
So that,
N is the exact same value as 0.61
that she said it.
because we said it was. We created it that way. Got you.
so can't you do that? Yep. Can I just take a letter like this?
Sure. There's nothing special about N.
So is this like an actual real question? Do we have a question?
Oh yeah.
So we just say whatever Q is.
Yes.
That's not what you're telling me.
Yeah, but that's not the problem. We're not done with the question yet.
Oh,
We're
actually,
That's what I'm
We're
saying.
so not done.
Oh gosh.
But we're really close.
So are we dividing now?
Yes, we are going to divide now. Yeah. All right. So the goal is to figure out what N is. N is actually 0.61 repeating. Hey guys. N is 0.61 repeating, right? What I'm trying to figure out is what does N look like in fraction form? It looks like 61 over 99. That's right. Oh, sorry. The right number. Well, we do as long as it doesn't factor. So N is equal to 61 over 99.
So 0.61 is.
Yes, and you can check this really easy. How? Get your calculator. You're gonna do course, aren't you? What is 66 over 91, or 61 over 99 look like? 0.616161. Well, eventually it says 2 because your calculator doesn't know what to do with it, yeah. You so need to see another one, don't you?
Yep.
Okay. You ready?
The next one's the same thing.
Not quite. What's different about this one?
It's just the one is repeating.
It's just the one repeating. So if we were to actually write this out, like we talked about earlier, it would look like this. So the answer is not going to be 61 over 99. There is some other expression for how to deal with this. How many numbers are repeating? One. That's important to remember, okay? All right, so we start out doing what?
N equals 0.61 repeating.
N equals 0.61 with the one only repeating. And we times it by 10. Why, Hannah?
Because there's only one number repeating.
Right. We times by 10 because there's only one number repeating. You see what that does is it moves things far enough that things line up. If you multiplied the last problem just by 10, what would happen is that the 6's and 1's would alternate. They wouldn't line up. So we're only going to need to multiply by 10 so things will still line up. All right, so I've got what on the left? 10n. 10n, right? All right, so now think with this over here. Think about it from this perspective, perhaps. If you take this and you multiply by 10, what do you get?
6.11.
Yeah, 6.11111, right? And I mean, I could write this as 6.1 repeating. That's true. But then the 1 repeating doesn't line up, does it? So what I'm going to do is I'm going to write it like this. And the only reason I'm doing it is because I want the 1 with the little repeat to be in the same spot. Okay? It's kind of like leaving a fraction in sort of a non-reduced form in the middle of a problem because it's more helpful. Because then I can add it to something else easier. Or something.
What do you mean that it doesn't line up? Like, I don't understand.
Okay. If I write it this way and I compare it to the number like this, the 1 repeats are not in the same location right now. One of them is in the 10th spot, right here, and that one's in the 100th spot. The 1 repeat just doesn't line itself up. They aren't right on top of each other. So see, what I'd like to do is I'd like to take that original 6-1 value and subtract it off. And if I've got the 1 bars lined up in the same spot, they subtract away and they're just gone because they're identical. But that actually leaves 6.1 minus 0.6.
I don't get why you're subtracting points.
Yeah, how can you subtract points?
Our goal is to get the 1 repeats to go away
Well, why would you subtract 0.11?
because that's not what n is.
Oh.
The only thing that you have a name for is the n equals 0.61 you started with. So when you get to this spot right here, you will always subtract n from the left and whatever n equals from the right. Always. It's the same. Always. It will always look like minus n and minus whatever that n value was that you defined up here. And that's why I want that 0.1 lined up right there. Okay. And then I don't have any repeat bars left. In fact, on the left I have 9n. What do I have on the right? 5.5.
So can we just look at it as a
Yeah, they subtract away. The repeat bars are matching up, they're identical, so when we subtract them, they add to 0, they add nothing. Exactly right. Okay, this one sort of feels like you've got it finished. You're actually not quite done on this. What do you need to do next? Divide by 9. But I contend that you're not done right here. What's wrong? You've got a decimal over the whole number, and you were told that you wanted to write this where they were integers, right? How do I get that 5.5 to be an integer? Multiply by, how about 10? Gonna multiply by 10? And it's really 10 over 10, right? So what does the 5.5 become? 55. What does the 9 become? 90. This isn't reduced though. It will reduce now. How? Okay, so what are you dividing by, Ashley? How are you reducing?
I'm sorry, I was lost. I was
Maybe I saw her hand.
Oh, yeah, 11 divided by 5.
You're going to divide by 5. So yeah, they both have a 5 in common. Sorry, no, I'm sorry, Ashley. I thought I heard your voice.
No,
Yeah, they both divide by 5, right? So in reduced form, it will be 11 over 18. All right, so grab your calculator once you put 11 over 18. Does it work?
Yes.
So here's the cool thing about these problems. You don't need a back of the book. Right? When you get, listen. When you get to the end, you know whether it's right or not because you can check it for yourself. So that's a really good thing. It's a good thing both on your homework in section B because you don't have a back of the book. And it's a good thing on exam because you don't have a back of the book. So if you've made a mistake, will you know it? Yes, you will. Because it will not be the same value you started with. All right, let's see what's next. Are you guys ready? All right, a little bit different question. We have a decimal that is 0.9 repeating. We have a decimal that is 1.1. And we're supposed to find any decimal between them on part A. And then on part B, we're actually going to find the actual halfway point between them. So let's start with any decimal between them on the first one. What could we do? Sure, you could. So you can kind of look at this like it's almost like money, right? Now the repeating business here is a little bit weird. So, if you want to write out something that sort of looks like what it really is, you can sort of give yourself that picture. But then this is the number that looks an awful lot like $1.10, doesn't it? So you have lots of options. One option would be what Kinsey said, which is 1.01. That'd work. What's another one? 1 actually doesn't work. We're going to talk about why in a minute. 1.02. 1.022. Yeah, lots of work, right? Once you've got one, you've got lots, right? The easy ones to think about are in terms of money, I think, on this particular one. They're really nice because you've got $1 and 1 cent, 2 cents, 3 cents, and so forth. All right, to find something halfway between, well, there's a couple things we could do. One of the things that we could do is that we could simply do what you would normally do to find the number halfway between two numbers, which is to add them together and do what? Divide by 2. Now, in your calculator, the way you can handle that is just put that decimal point with the 9 a lot of times. Your calculator eventually doesn't like it because you put so many 9s in there, but you'll still get the same right answer. So if you take your calculator and you put 1.99999 plus 1.1, press enter, and then divide by 2, it's going to give you something into a form that you're going to write with the proper number of repeating decimals. What'd you get? Did it actually give you 1.05? Okay. Some of your calculators might have given you this.
Yep.
Some of your calculators might have given you this. Any idea why? It's not because of rounding.
So because I
This
calculated.
calculator what?
Mine says 1.0499.
Because of your decimals, yeah, you just need more 9s in there.
Mine has like 5 9s and then a 5.
Yeah.
I wonder if we could do like as
Well, I'm about to show you something that you should do. Ready?
Slow our minds.
Huh? Blow your minds, you're Morgan? Alright. Let's take a moment, and I want to figure out what in the world 0.9, or the 9 repeating, I want to know what it looks like as a fraction. Okay? So we're going to do the same thing we did on the last 2 slides. You with me? I know you guys love it, so we need to practice it one more time, don't you think? How do you start? N equals
Check it out.
0.9 repeating. Excellent. That's the first step. Very good. What's the second step? Multiply by 10. And why 10? Because there's only one decimal that repeats. Okay, so what does it become on the left? 10n. What does it become on the right? 9.9 repeating. Okay, so this is the step that some of you just freak out on me. Don't freak out. It's always the same. Always the same. What's the next step? Minus n. Thank you, Lydia. Yes. On the left, and what is it on the right? Minus 0.9. Okay.
That arrow's
What'd you get on the left, Hannah?
Well, 9 in.
9 in. What do you get on the right? 9. Now what?
Divide by 9.
What's in?
1.
Is that right?
It is right.
What is life?
0.9 repeating is the number 1. Now, I want you to think for a moment. You actually knew that that was true, even if you didn't realize it. Do you remember what 0.3 repeating is? 1/3. So what happens if you add 0.3 plus 0.3 plus 0.3, all repeating? Well, you get 0.9 repeating, right? Well, what happens when you add 1/3 and 1/3 and 1/3?
1.
You get 1. One of it is a repeating decimal viewpoint, and the other one is a fraction viewpoint, right? 0.9 repeating is exactly the same as 1. So it makes sense that we should be getting 1.05, right? Because halfway between 1 and 110, think money, is 105. That's what it is. How crazy is that? Crazy.
So
Alright, let's
wait,
take a look.
so
Oh,
like-
sorry. Yes.
So then, is it 1.05? Like, is that, which one's the right one?
There are two ways to express the same thing. These are both identical answers, they just look different. It's kind of like giving an answer as 1/3 as opposed to giving an answer as 0.3 repeating. They're the same. It just depends on what you like to look at or what the answer, how the question was asked.
Okay.
They're equivalent.
So we solved that way, and
Huh? Oh, no, I'm sorry, hang on. This was an aside. This was the blow your minds bit, right? That's what you asked me for, right?
so do you want us to work it out like the first way and then show the other way too?
Everything that I put in the black box was justification for why those two values were the same. That's all it was.
Oh, okay.
Okay?
So
It really wasn't part of the problem.
The two values are like answer,
Yes.
and then like if on the test you'd be like why.
Yeah,
You would do it
that's
that way.
exactly right.
Okay.
If I asked you on the test, why in the world is 0.9 equal to 1 or whatever, right? You should be able to work through that and show why that works.
Okay.
Yeah. Okay, one more question. I don't even remember what it is. Let's see. Oh, okay. So I can't even remember who was in my office. It may have been Abby. And we were talking about that you didn't, was it you that we were talking about not having seen a lot of fraction stuff before? Was it someone else? No, was it you, Angela? Yeah, it was. I remember now. Okay. So one of the things Angela had said is that she had always really thought about fractions in the sense that you turn them into decimals and you work with them from a decimal point of view. You guys have a lot of that going on in your mind?
Yeah.
And it works some of the time, but there are cases, very honestly, when working with decimals is not very friendly. Now, you can work with approximations of decimals and be friendly, but if you're working with exact decimals, it's not always friendly. So here's an example. Some addition problems are easier to compute with fractions, and some are easier to compute with decimals. For example, 1/7 plus 5/7 is 6/7, right? It doesn't take very long. You're looking like I'm speaking foreign language, I'm not sure why. 1/7 and 5/7 is 6/7, yeah?
Yeah.
Sure enough. What about here? What is 0.142857 repeating plus 0.714285? I can't even say it repeating.
That's too much.
What is it?
A big repeating?
Yeah, it's 6/7. You're exactly right. It is 6/7. But I don't really think you really want to add it with the repeatings the way that they are, do you?
No.
It's not friendly at all, right? No, not friendly. But then if we have numbers like this one, 0.4 and 0.25, well, I'd like to add those in decimal form just fine. That one's easier to work with than 2/5 plus 1/4, which are the equivalent fractions, right? 0.4 is 2/5 and 0.25 is 1/4. It's not difficult to work with in fraction form, but it's easier to work with in decimals. So what's the difference? Can you describe when is it easier to work with fractions? When is it easier to work with decimals? So,
Oh.
just because I was talking too long. All right, so let's start with fractions. When would it be easier to work with fractions? Okay, that's decimals. That's okay. Let me write it over here too. Decimals are nice to work with when they're terminating, right? And I would even contend, Kenzie, that if they're terminating and they're short, I mean, I don't want a decimal expansion that has 6 or 7 things. That's probably not also very helpful. So if there are few decimal locations or decimal places. something that's terminating with a few decimal places, that's kind of nice. When is it easier to work with fractions or easier potentially? Common denominators, you bet. Common denominators?
When they're small.
When they're small, you bet. So if I've got small fractions, and by small fractions, I mean that the integers on top and bottom are small numbers, right? So I've got numbers like 1/4. That's actually pretty nice to work with. You guys think of any other ideas?
When you're dealing with concrete things, it might be easier to do fractions, like half of a cookie instead of 0.5.
That's very true. It really depends on the concrete things you're working with, doesn't it? Because if you're working with money, then decimals would be very friendly. But if you're actually working with dividing an object up, fractions would be better. Right? Think about dividing the pizza. I'm pretty sure you don't want to talk about the pizza being 0.33 repeating of the pizza. Real, right? You probably don't even want to talk about being 0.5 of the pizza because we don't really think about it that way. So I'm going to put it under both cases, this idea of concrete visuals, because it depends on the visuals. Any other thoughts? Okay. Go ahead and write these down if you don't already have them.